We get caption and we will work on the assignments first. And then we will work on our packet tracer. So this week we are going to touch on, let me move this to the side a little bit. We're going to touch on some of the commands for Cisco configuration. Now these are the general commands, but you will see that sometimes you would have specific service or commands that are not going to work for a certain model of appliance, and that's common. Also, it depends on the OS version that you use for Cisco devices, but I will give you some of the general commands on how you can get from turning on the device, your switches, all the way to how you would be able to configure it. Perhaps. So we will talk about router configuration and switch configuration, and some of the routers are the same as the switches, because if you have layer 4 or higher switches, that means that those switches can route. You would be able to adapt some routing configuration command into it. So the first thing that you're gonna see is that there are 3 modes in how you access these devices, plus you. When you turn on the device, plus you, and normally we would use an application called PuTTY, P-U-T-T-Y, to be able to directly connect with the device through a terminal. You can use Telnet, but it's not secure, or you can use SSH. So in the later labs, we will see that we will be able to connect into the switch or the router, and you will be able to configure it. So once you connect, you're gonna see a command line interface that's gonna open up. And the first thing that it's gonna be blinking is going to be the name of your device. So by default, Cisco normally gives you like S1 for switch 1 or switch or router. And it's gonna be having an arrow, okay? And when you see the name of your device and the arrow, you are in the user exec mode. This mode is a read-only mode. That means that you cannot configure in this mode, okay? You can view information like settings in this mode, but you cannot change your settings in the user exec mode. So there's no modification in this mode, okay? So the first thing that you see when you see the name of your device and the arrow, that is a read-only mode, the user exec mode. Now to move from that mode into the next level, you're gonna type in the command enable, okay? Enable allows you to change from the read-only mode into what they call the privilege exec mode. And in this privilege exec mode, you're gonna see your device name and a hashtag, and that's the difference, right? So you're able to change some device settings in the privilege exec mode, okay? But you cannot do additional configuration like adding VLANs or changing IP address until you move to the third mode, which is what we call the global configuration mode. So when I turn on my switch or router, I would see the user exec mode. I would type in the enable command to move from the user exec mode into the privilege exec mode. Then once I'm there and I want to configure my system, I will type in a command called config term. You can do configure terminal or config term. And at that point, you are gonna see in your path your router name or your switch name, and it will say config. So if you want to change settings, you have to go from the user exec mode to the privilege mode and then the configuration mode, okay? By typing in enable and then config term. And that's for all Cisco devices in their CLI using iOS. Now, if you buy a new device, like some of the devices that we bought for business switch, it completely used graphical user interface because Cisco realized that not everybody knows how to administer in the command line level. So they have implemented operating system that allows you to use your mouse to click. Now, some of those devices, you are still able to use CLI. Some of the model doesn't allow you to use CLI. Now, so when you use your Cisco devices, you just need to make sure that you know the operating system version. If it is not the latest version, it might not take some of the existing or newer commands, right? Like I said, you can have a catalyst, which is an older switch like this, and they normally would come in like blue or like a dark green color. And these catalyst switches, they're still around and they're still being used, right? They've been around for a long time. They only take a specific command based on the services that's allowed on here. So for example, if you're trying to make multiple VLANs on these because they are not capable of having a lot of VLANs or handle layer 4 or higher. So you have to take a look at the capability or the feature of your switches. So sometimes you can make only a default VLAN on these compared to some of the newer switches. And they mostly would start the same way as the newer switches or router, okay? So let's go through and answer some of the questions so that way you are more clear. The question 1 that says, when you're using Cisco router and managed switch, which mode is used to configure the device? How do you access such mode? So you need to go from user exec mode into the global configuration mode. That means that you need to use configure terminal command or config term in the privilege exec mode. And to get to privilege exec mode from user exec mode, you would start with typing in enable, right? Oh, I put that already in the following. So to start, when you start the system, to get to the privilege exec mode, you have to type in enable. So when you turn on your switch or device, usually it's probably already on, right? But it's always going to revert back when you exit the configuration. It's going to come back to the user exec mode or read-only mode. So you would see the arrow, and when you see the arrow with your device name, you would type in enable. And then you would get into the privilege exec mode. Once you're there, you type in configure terminal or config term. And that's going to allow you to see config in parentheses next to your system name. And you would then be able to change the configuration at that point. So I have a lot of students in the past and they don't know exactly which mode they're in. So they're trying to use specific command in the user exec mode and it throws error, right? So you need to ask yourself, which mode am I in and what am I doing? So if you just viewing settings, you can definitely be in the user exec mode, which you see the arrow. Then if you want to change some of the settings, and we'll see this, right? For example, we want to be able to change like date and time or something like that, then you can be in the privileged exec mode. But if you want to add an IP address, a subnet, if you want to create VLANs, you need to go into the configuration mode, which is you would use config terminal or config term. So there are 2 steps in order for you to get to the configuration mode, and that's called the global configuration. And in most of your devices for Cisco, you would use your command line interface only, right? Like I said, some of the devices, the newer devices, they would have an option to use graphical user interface and command line. Basically, it is embedded Linux. So most of the command that you see in Linux would correlate with what you see in Cisco, like IP space address, or, ping, that would also work. So you would be able to use some of the commands. Because when they create the operating system, they just basically use the kernel from Linux to be able to build some of that. Now your switch and router have processor and RAM. And sometime you would have EEPROM for just the general startup setting. Now when you access certain tables, like what we talked about before, like a switch table or a routing table, you would actually view the storage information. So that would be on RAM. Now, so as you enter the field, you're gonna see data centers that are really equipped for AI. So those appliances require higher processing hardware. So you would have like digital twin type of processor. Or you would have different processor that would be able to have throughput in the terabytes versus gigabyte, right? And so they would run hotter, right? And you would see that these data center consume extremely massive amount of power. So one of my students was mentioning that OpenAI planned to have its own data center in the United States in the near future, and based on their estimation, just to have that full-fledged data center, it would consume close to half of US power. So what they're doing is they're probably gonna pull a lot of the public power that you see from like solar and other things to be able to support it. But when Broadcom presented at the conference that I attended in San Jose, they were saying how much power that they need to be able to accommodate these network devices. And it's incredible, right? So you do see some aspect in resource consumption as we move forward with artificial intelligence and networking. So in the second question, it asks you, in Cisco routers and switches, which mode allows setting changes but cannot be used for configuration? How do you access this mode? And from a user exec mode, when you first see that's the first mode that you see, you would type in enable as a command. You can type in en, sometimes that will also work. But enable will allow you to go from the first mode to the second mode, which is privileged exec mode, and that allows you to change some settings. But so when we say settings, that will pertain to system settings, but not configuration. Okay, configuration, like network configuration, needs to be at the global configuration mode, like what we said in number 1. And so for the third question, the purpose of the user exec mode is to view your device settings, right? Like I can say, show VLANs, so to see how many VLANs I had set in the other modes. So if you configure and you have it stored to the memory of the device, right, or the storage of the device, then you would be able to view it. You can also say like show IP address, right? So it's basically a read only. You can only view information. The reason why we do that is that automatically when the device is accessed, we don't want people to go in there and modify the device. Cisco routers and switches don't get shut down only when you are running into issues or troubleshooting when you restart the device, or when you replace the device is when you shut it down and swap it with another device. But we don't turn them off because they are transit system, right? It's like shutting down the road. Who's going to be able to drive on, right? So we want to make sure that they're on so that way we have network communication. Okay, so to access the global configuration mode, once again, for number 4, we would start with enable as a command, press enter after that, and then we would type in config term and press enter, and that's going to take you to the configuration mode. So in order to change my router or switch name, I have to be able to go from the user exec mode into the privileged exec mode, and then the global configuration mode, which allows me to set the name. And just like Linux systems, you're going to use the host name command. And after this command, you just basically set the name that you want. So if we want to change our router to site 1R1 for the router 1, you just make sure you access the global configuration mode from where you are, and then you type in host name and the new name for your router. So initially, if you open the box and you turn on your router and you connect to the router through your computer, right? You would do these steps to name it, okay? Normally, the system would prompt you to set its name. Do you want to change the router name or the switch name? And you can go through the prompt to be able to do that, just like how Microsoft gives you the wizard to walk you through the steps. So most of the device, it should ask you that, but in the case it doesn't, this is what you do, okay? So we will practice more, and you will have access to the devices, so you will be able to turn them on, connect to them using a console cable. So Cisco devices use console cable, which is either a serial or a USB connecting to that. So when you look, right, in the front is all my ports that I would connect my computers to. And then in the back, you would have a power connection, and normally there's a port called console. You don't connect the computer to the console like your client devices to the console. You connect your computer that you use to configure to that console, right? We call that, those are the terminal systems. So it could be a laptop or a desktop. And normally they would use Ethernet connection, and you can use it to the serial or a USB. These cables normally cost about $10, and now there are mostly USB-C. So when you use it, and they have specialized chip to be able to convert the signal. So these console cable, if you buy directly from Cisco, they're a little bit more expensive than if you buy it, more on like Amazon or a more generic kind. So back in the day, these used to be serial cable, but now they are all USB. So you're able to have more throughput and when you connect directly to it. Okay, so in the front, you are going to have different types of transfer rate for your port, right? These are going to be for routers and switches to have throughput for communication. So if I'm connecting mini desktop to my switch, right? They are rated for specific transfer rate. Catalyst, the older switch, might be at the fast Ethernet. Or if you use an older switch, that might just be regular Ethernet, okay? So when you're using the Ethernet ports, that will be the ports in the front, or sometimes for the back, those gonna be 0 to 10 megabit per second. So we can say that the maximum speed for Ethernet is gonna have throughput about 10 megabit per second. Now, as you see with the AI center, those switches are made with faster processor, and the port connectivity and the cable that they use, right? They use Ultra Ethernet, which is gonna allow it to have throughput at 1 terabyte per second. That's incredibly fast. Okay, so you need AI to absorb all the data, right? Apply that into the algorithm so that way it can spit out decisions. But at the same time, we have to make sure that the data gets brought into the network quickly. But traditionally, networking is still functioning at these rates. So if you have some of the newer switches and routers, they are going to be at fast Ethernet. So when you see FA, that means it's fast Ethernet, okay? Sometimes that they are shortened. So you would type out the port number, you see that later. So fast Ethernet transfer up to 100 megabit per second. And then you have gigabit Ethernet, and Ethernet is used inside our LAN, right? Gigabit Ethernet transfer at 1,000 megabit per second. Now you might have routers on the backbones that use fiber optic, right? And they have higher throughput, but normally we use fiber optic to route things in and out of the network. So you tend to see that more on the router. If companies have switches for like location, like campuses like this, sometimes they would use fiber optic, and you would have specific port for the fiber optic. Normally you have a fiber optic box, right? That terminates, and then they would connect in Ethernet directly into other devices. You don't see a lot of like fiber optic line running directly. There are some networks that have that, but they are very pricey. So just to get that set up and transition. So at the data center, you might have something like that, but you don't normally have that in the network. So here at Moreno Valley College, you would see that we would have a fiber box. And then from the fiber box, you would see all of these Ethernet cables and switches that would transfer, right? We would use that to interconnect to the rest of the network. So ultimately, everything else is Ethernet, and then it would get brought into the super highway, right? Which is going to be your fiber optic. And that is more feasible in the regular network environment. Okay. So let's come back to the notes real quick before so you can find information and some example here. So in the case that you want to refer to that, and then it talks about the speed. Now, serial is something older, right? You might run across like an older switch or router, and the serial cable it's similar to your VGA. It is a D connector, and it has like these two little screws on the side to be able to connect. Now, just keep in mind that serial is a slower type of connectivity. And you do see some routers and switches that might use this. A lot of the time, if it is a router, it's going to interface for the wide area network. So you would be able to connect one Cisco device to another using a serial cable, and you have to buy their cable. And so if you are working with some of the older devices, you might see that. So my analogy for serial is like this. You can have a bucket and you need to gather the water, and serial is like collecting one drop at a time. Compared to what you see now, right, in the higher speed area, you are you have communication in the system that I can collect 1,000 drops, 100 drops, 10 drops at a time. So what you see is that you have higher throughput in the newer modern devices, but in the case that you have the older devices, serial is just a way to communicate, and it was a slower connectivity. Okay, so we talked about fast Ethernet, right? So in order to access the actual port, for example, okay, I want to configure this port, the first port or the 24th port. The way that you use the command is you have to say interface, okay, and the port number. And the F stands for fast Ethernet. Sometimes it's labeled as FA. So before you start digging in and configure specific port, and you might run into an error, in the user exec mode, you can actually view the table of all your ports, okay? So you can say show interface, and it's gonna list, if it's 24 ports, it's gonna list 24 from 0/0 to 0/1, etc. So it's gonna go from the first port, which is the port 0, all the way to the 23rd port, which is the 24th connection. Okay, so you can show something like that. So to access that specific one to configure, you have to put in interface and then the port value or the ID of the port, right? So when we say FA or F0/0, you know that is fast Ethernet. We talked about the rate for that already. So it is the first Ethernet port on that switch, okay, or that router. And then from that interface, let's say I want to give an IP address to that interface. Then once you do interface and the number or the ID of that port, it's gonna then bring you to, you're gonna see your path, it's gonna say config if. So config if just means that you are configuring that interface that you have selected, and then you can type in an IP address. Normally, we would type in an IP address and a subnet mask, but if you don't type in a subnet mask, it will use the default subnet mask for the class. So if you're using a specific CIDR or subnet, you have to put in the IP address and subnet mask. Okay, so from when we are in the configuration mode, you can go into the specific port by typing interface and the port number. And then you can specify like the IP address or anything you want, like the speed of that port. You can regulate how the port transfer by putting in speed and the number. Okay, so for example, I want the first 10 port to be slow because I want to reserve my bandwidth for the next 10 port to be fast, because the department that use those ports, for example, like finance department, they need to do like, account transfer or whatever for the bank, then we want those ports to be faster. So you can regulate it. It's kind of like how you have speed limit on different part of the highway, the freeway, right? So that's what you can do. So let's go through and answer some of these questions. Okay, so for number 6, it tells you that these are the things that you need to configure. First, you need to put in an IP address and a subnet mask for your port. Okay. And then you need to put in the description for your device. And then you need to put in the speed. And you need to put in the transmission type. And you want to activate that, enable that interface. Okay. So these are the things that you need to do as a network technician, maybe, or, a person that troubleshoots. So first, like I said, you need to be in the configuration mode already to do that, right? And then you need to make sure that you are in the right port, the interface. So I would want to say interface and the port number. And then to fulfill A, I would type in IP space address and then put in the IP address. So this is for a router. You can see because it's the .1. And then it uses the default subnet mask. This is a class C address. So you type in the IP address and the subnet mask. Then you say that I want this to be full speed. So I would do speed 1000. So if you reduce this value, that just reduces the speed for that particular. So I can say 600 or 500. So if I want it to be half of what the maximum capacity, assuming that it is fast Ethernet, right, or a gigabit Ethernet, so it's at 1000 megabit per second, we can make it a percentage of it, like 600 or 500 or 400. And then you want the transmission to be full duplex. That means that it can send and receive together, right, at the same time. So once that's done, we can do no shutdown. Now, keep in mind that no shutdown might not work for some of the later different OS versions. So as they build some of the OS versions, they deprecated some of the commands. So just know that this is typically the command that we want to enable that interface, but it doesn't always work for all. So my best recommendation or suggestion for you is before you start configuring your device, make sure that you look up the manual for that model. Cisco have discrepancy in how, it's not exactly the same for different models. Even you go from one model to the next model, some commands might not be continued in the next OS versions. So just double check before you start working on it. And then if you work on it and you get stuck with certain command, look up the manual. It's all in PDF on their website. And so that way you know how to work around it. Okay. I still have to reference it. That's the challenge with using some Cisco devices, is that you might not have, and if it doesn't have a certain service, you cannot use specific command. So you need to make sure you check the specification for that device. Okay. Any question regarding how to set IP address? So you will need to know these commands for our quiz and final, and then also our labs in the future weeks, right? We're gonna spend a little bit of time on Packet Tracer. Next week in Packet Tracer, you will have to access the terminal to give it some commands. And I do have the steps for you to go through. And I would encourage you to use Packet Tracer so you can practice outside of class when you don't have access to the actual hardware, right? There are companies that use Cisco switches and routers for very cheap. So if you want to find those and be able to practice more, so that way you can put that information on your resume. Now, when you add these information on your resume, you need to make sure you put like the model of your device. IT people, they care about that when they look at your resume. So for example, I've worked with many catalysts, right? The 2000 series, the later series. So I put those series on my resume. So somebody, when they look at my resume, they would know that I have experience in configuring that. If you work with like the later routers, or switches like the 5000 series, put those in, and they are different, right? So you're gonna see that like the SX is different than another model. So that's important. Now RCC does have a Cisco certificate, and it's part of CIS 26. If you want to dive a little deeper, you can go through and take those classes later. But I personally, I didn't have Cisco certifications. I just started practicing and using, and I didn't have a simulator either. So I was using a lot of these devices by practice, just like offline, and so that's how I was able to get better. So that means that what? You don't have to have Cisco certification to get some of these networking jobs, right? Cisco certification just makes sure that you are able to work with Cisco devices. But in the industry right now, you will have many different companies, including some of the large company that supports data center like Jupiter, right? So you're gonna see that Juniper and some of the other companies, like even HP switches, right? And they use different commands and they use different setup procedures. So okay. For serial port, what you would see is that you would see something like this, where you can also put in the interface. You notice that the interface command is the same, but because it is a serial port, you have to say serial and then the port ID, which would be the first serial port for that particular appliance. And then to obtain the IP address from the DHCP server, you just do IP address and then DHCP. Okay. Now there are two ways to link with encapsulation. So the way that encapsulation work is, that encapsulation is a way that we can prepare the information, right, from one system for the next system. So it would carry the data and be able to have that ready for the other system environment. So you can use an encapsulation command and you can set your type of link. And HDLC is high data link control protocol used for serial port on the older appliances. It is specifically for Cisco appliances only. So if you are working from one Cisco appliance to the linking it to the next Cisco appliance, you would use the HDLC. But if you're using a Cisco appliance and you're connecting it to Juniper appliance, then you would use PPP for point to point. Okay, so that's how it's able to connect. So everybody else use the triple P. Only Cisco serial connections to Cisco device uses the HDLC. You understand? So Cisco have proprietary protocol that they specifically use for their appliances. And so that's what's kind of different about Cisco's, you would have these specific protocols. All right. So it talks about clock rate. This is how you can set your rate to link your data, right? And then you would say clock space rate and then put a value there. So 64,000 for this one. We would connect it with a serial cable. So this is how you can link your routers together with serial cable. Now, will you have to set up something like this? No, right? Most serial devices have been replaced, or they are being replaced. But in the case, like I said, if you walk into a very old network and you have to fix it or you replace it, you would see this, right? And you would know how to be able to go through and troubleshoot it. Okay, so for 7, it asks you which serial link encapsulation protocol is used to connect a Cisco device to another Cisco device using a back-to-back serial link cable. That will be your HDLC, high data link control protocol. And then the command that you would enable the interface, the port that you configure after you modify it, is called no shutdown. Like I said, right? Most model will accept that, but if specific model, if that doesn't work, then you have to see if there is a newer command that's being applied. So after I configure, I want to put this information into the startup configuration, so it stores it, so it knows. So for example, I want to activate some services for that port, and as the system started, it's going to turn on that service. For some devices, some switches, you can enable DHCP, and so on, right? So what you see is that you want to store this information into the configuration mode. So you are going to copy the running configuration, which is what you have set, to the startup configuration, so that way it would be applied, right? Like IP addresses, subnets that you would set for the VLAN, so that way when your device starts, it would have that information to refer to for ports, for connectivity, for the services that you use. Any question? So I want to go through this so that way when you are working on your lab next week, right? Today's lab is kind of easy. We don't really have to do much with the actual Cisco Onion simulator packet tracer. But in the case that you will access your Cisco devices, you would know how to start, right? And then be able to type in specific commands if you need. Okay, so the command for copying it to the startup configuration, you can see that there. And when you do that, it would take like maybe a few seconds for it to go through, depending on how fast your system is. So let's talk about like how we really divide up the network, right? And so normally we look at different part of the network as zone. And when you draw your topology, it really, you have to think about like how these zones would be applied. And in cybersecurity, it's also important for us is how we would protect specific zone. Because ultimately, if your network is vulnerable, then your systems and your data becomes vulnerable, and your systems and your data are assets. So want to make sure that we have the proper protection for different area. So you have the private LAN that's inside your network that would consist of your devices, your desktop, your laptop, the servers that would provide service to your regular operation. Let's say that if we're looking at a store, right, these would consist of sales terminal and along with, the database for the inventory, and then also for the employee systems that would be part of the network. So that would be your private LAN. Then almost all network now have some kind of wireless. Now your wireless should be also segmented. So you might have a wireless segment that is for your employee. Like a hospital, you would have nurse that would have these laptops or tablets that they would use to document diagnosis or update files, and the doctors would be able to use these wireless devices. So that is also part of your LAN. So that means that my access point needs to be connected onto a switch for my private LAN, right? Remember we talked about how you drew the topology in lab 1, and I keep saying, oh, you can't put your AP onto, so normally we don't use just like a regular wireless router. We have a switch, and on the switch, right, you would connect your access point at one port, okay? And then we would have another access point for the guests. Like if I'm looking at a hospital, that will be the visitors and the patient that comes and stay there temporarily, right? So that will be on another port, okay? And then you have a DMZ. These are gonna be your public servers, okay? Like web servers, you're gonna have a lot of traffic coming in from the internet that's visiting the web servers. You might have a DNS that will be connecting to the web server, like for myhospital.com, right? So that DNS is tied to this web server. You might have mail server, right? SMTP, that will be for specific access. It could be for your users, your account that is for the web, right? Like if I'm a patient, I can create an account, and so that way I can set an appointment to see my doctor. And through that account, I'm able to receive messages of my appointments, right? Like what I need to bring, or what is my next appointment, if there's a follow-up appointment. So you might have an SMTP or a mail server there. And then sometimes you do have some public database that doesn't have sensitive information. So in the DMZ area, this is part of your network. But before you get from the DMZ into your private LAN, what do you have to place there? A firewall, right? So coming in from an internet, if we're drawing that, we draw a little cloud. And then from that little cloud, let's see if I have some kind of marker. From that little cloud, you would see that they have, from the cloud coming in, you would have the DMZ area. So now these servers need to be protected too. So you normally have an application firewall, which is usually software oriented, or you might have an appliance. So that firewall is in charge of making sure that things get blocked, like attacks, or you might have, some type of intrusion prevention system for this area, okay? But you're gonna have massive amount of traffic. So this part of the network, you need to make sure that it has high throughput, because if you have millions of people accessing your web server, it's gonna throttle your network for sure, right? So that's coming in from the internet. So we wanted to benchmark and see how much traffic we have there. And then from this network, in this part of the network into here, we would have maybe a border gateway and then protecting with a firewall there, okay? So that firewall at the edge is going to make sure that it's gonna block everything coming from here into here, okay? And then inside this network, we would have an intrusion detection system or an IPS. Now from here to here, right? So when you're looking at that, it's a switch on a rack. There's a router on top of it on the same rack, right? An access point connect to it on the same rack, right? Everything is on the same rack. But logically, what we do is we have another appliance that will be the firewall connecting to the uplink switch to make sure that from here to here, we're protected. From here to here, we're protected. From here to here, we're protected. So implementation for security, you have to look at your zone and how you can protect that. And then internally, we want to be able to apply rules so that way, right? It would check against those rules to fulfill whether it passes the traffic through or not. And that's how you have network defense, right? So CIS-27 should address a lot of the protection for this different zone segment, but you know, so these are some of the zones and you can grab it from that section. So keep in mind that your LAN is internal network. All your essential server systems for employee that belongs here, right? And we need to make sure that this is protected. The wireless, right? Coming in from the wireless. So why can't I just throw wireless in here and just that way I can monitor it? Well, this should be a subzone from the private LAN. Like I said, that access point, because wireless is very vulnerable. Anybody can scan anybody on the wireless once they're on there. So you can run Wireshark to be able to see who's on it, what's talking, what kind of services you're running. So between your guest and your regular wireless, so your guest wireless is mostly wide open, right? We don't put anything on there. And like RCCD, we want to have terms of use so that way people know that if they're using it to pay their bill, they might be vulnerable to information leak, right? We're not going to be responsible for that. But your internal wireless, this is a subzone for your private LAN. You want to make sure that you monitor and protect it as well. Okay, so we set policy for these and we can use application firewall or regular firewall rules to be able to support that. And then if you take ethical hacking next semester, you will have a big old chapter on different types of firewalls if you don't cover that in CIS-27. Any questions? Okay, so these are some of the zones. And we can also use segregation using IP addresses. Okay, so now, sorry, before I answer these protocols, I want to point you to your notes real quick. So let's talk about switch. And so these protocols that you're going to see next is really addressing, right, the switch services that you see. Okay, so spanning tree protocol was really designed to prevent flooding or continuous looping. This is a way that the system can take the loops and place it into a blocking state so that way it doesn't take up a lot of bandwidth. Because if you don't do that and it continues to loops, you will have degradation in network performance, and also you will have non-communicated system because it's keep looking for things. Switch tends to do a flood. Basically, it asks everybody, right? So initially, when you turn on your device and the first time that any device connecting to a switch, right, it needs to kind of broadcast and say, who is connecting? It's like I'm walking into the room and I ask everybody, what is your name, right? And everybody would tell me their name and then I would record it down. So that's how the switch would have the switch table. This is kind of what you see in with ARP command last time with the utility. But if it continues to do that, it won't be able to have any kind of forwarding from one system to the next. Okay. So SCP is really designed for that. So for 11, it asks you to explain how SCP is used for loop avoidance. We want to, it plays the ports that's involved in the loop. It could be all the ports, or it could be specific number of ports, like 1 or 2, into a blocking state. And so when it goes down, the loop avoidance protocol, the STP, is then going to detect it and making sure that there is a secondary pathway so that way it can forward. Because if it doesn't, then your port becomes inaccessible and it cannot communicate. So whichever system that's connecting to those will not be able to communicate, right? Now, for the switch, layer 2 switch uses frame, and we talked about frame before, right? Frame is a way that the system can structure your data and prepare it for transit, prepare it for the router. Okay, so the switch, it handles the frame, and so in that case, when you have flooding, that means that it sends all the system the MAC address information. Because it's like saying, I don't know who that is. It's like I'm walking into the room with a loudspeaker and I'm announcing, right? That I don't know everybody's name. Like it needs MAC address information. So if it doesn't have a specific MAC address, it's gonna say, who is this MAC address? But it sends it to all the system. And that's when you have flooding. Okay, because it broadcasts, it tells, it asks all the system, and it might multicast to the system. It's going to say, who is this MAC address? I don't know who this is, right? Whereas it should be that it's only going to look at a specific system and say, is this your MAC address, right? So that's what we want. We want it to be able to identify which system is connecting, but not ask everybody, right? Who is this MAC address? So when it forwards, it's going to take that known frame or the frame from that known system, because now it has the MAC address. So once it has the MAC address, it's going to frame that. It's going to say, okay, now I know that system A needs system B information to be able to communicate. Okay. But when you do port filter, right, in security, we talked about like, oh, we want to do port filtering. What does that mean? That means that we would tie the systems that connecting to specific port, the MAC address for that system, right? So on the table, it's going to say system A, MAC address A, B, C, D, E, F, G, right, is for port 1 or port 24, right? Specific port. And only that system can connect to that port because it has the MAC address. It's kind of like how you have a student ID and only you, right, would be able to use that ID to access school resources. Okay, so that MAC filtering is a way that we can control specific system connecting and to specific port, and how that port is communicating with the rest of the network. Because if you don't do port control and filter, another system can be connecting to that port, like let's say an attacker can connect to that, and what they can do is they can utilize your private LAN connection to be able to access like your server or sensitive data on a certain system that has access to the server. So these are the important functionality of the switch. Basically, it does do flooding, right? When it doesn't know the MAC address, it would forward the frames So that way the system can be communicated, the source with the destination system. And then it will filter traffic based on the MAC address and the port that's assigned. In the case that if it fails, right, like if communication fails, let's say that I'm system A and I need to send something to system B, and somehow in between it got disrupted, or my data was it generates an error that my data did not get there, right? Your switch should see that and it should take that frame and resend. That's the whole point of using a switch versus an unmanaged switch or a hub, is that the hub doesn't care, right? If it gets there, it gets there. If it doesn't, oh well, right? But the switch, it sees that frame and it says, oh, this MAC address, the frame failed to get to the other MAC address, so I'm going to try to re-forward. And that's important. We want accuracy. We want, and it needs to be done in a timely manner too, right? So if you continue to have flood, then everything slows down because it can't recognize who's who in the room, right? Or which MAC address belong to which system. Okay. So later on, what you see is they also updated STP. So STP uses an algorithm to check the port for if it has a loop, right? So it's a way that it checks the signal to see if it's actually looping. If it's looping, then it goes into a blocking state to prevent it from flooding. Then, and this algorithm would take 52 seconds to change from the looping into the blocking state. So that's like a good close to a minute, right? And it uses IEEE 802.1D. So there are 4 states that it use: blocking, listening, learning, and forwarding. I know you saw listen when you looked at your ARC table last week, right? So your system is waiting. It's listening, it's waiting for maybe incoming, right? It's in the waiting state, right? It's trying to see if there's anybody communicating with it. So in that case. Now, learning is when it's updating or recording information, and then forwarding is when it's sending, right? So there are 4 states that STP uses. They upgraded STP to Rapid Spanning Tree Protocol, which is RSTP. And this is 802.1W. It is an improvement of STP because there's a slope here, right? That's a good minute. If you think about it, there's a lot of things can happen in a minute, right? From a user perspective, that might not be a lot, but like if you're looking at data center, a minute is quite a bit. If you have disruption and people continuously trying to access systems or your servers, that minute can be a while. Like that can cause frustration. So what they did was they got rid of the learning state in the RSTP. They only have 3 states now: blocking, listening, and forwarding. And those are the 3 things that's really essential to the switch. Okay. And what they added with this protocol is that it actually uses a port as a backup link for forwarding. Okay. So in the case that goes down, so if I have port 1 that is going to go into a blocking state because it's looping, it's going to pick up, let's say, port 2, another port. It doesn't have to be adjacent, so that way it can activate the forwarding process. So it's going to kick it over to another port, and that port is then going to forward to the destination system. Okay. So when this happens, it goes through a voting process in STP. So what it does is it's checking the neighbors to say that like which port's available, which ports is being used, and then that's how it's able to pick up that secondary port to do that. So networking is really about logical process in how systems handle things, right? Uh, and these protocols are really designed so that way we would have better communication in the system in handling the task for our communication steps. Okay. Any question regarding STP and RSTP? So if you go through some certification, it would ask about these protocols because they are essential to switch process on how it manages, loops and floods.
Question 12, could you go over how the frame is connected to the map?
Yeah, so your frame is a way that it prepares data, right? And in that, you would have information like which MAC address is the source, which MAC address is the destination, system A and system B, right? And so with that, if it doesn't have the MAC address information when it does the prepare, it's kind of like I'm putting things in a package and getting ready to send, but I cannot print the label because I don't know who it's going to, right? I cannot forward the information if I don't know the MAC address. So when that happens, it's gonna do a flood. It's gonna loop. It's gonna ask like, who is this going to? Which MAC address is this system B, right? The destination system. And when it continues to do that, you have a flood, right? Like if I cannot put the label down on who am I sending the package to, then I keep asking everybody, who is this package belong to? Who is this package belong to? Right? And it keeps doing that, then you have a flood. So the way that they handle that is that they create a protocol, which is a set of rules that the system would go through and check. And it says, okay, when this happens, instead of having a continuous loop and flooding issue, it would just stop it from having the loop, right? And then be able to block it. So it's going to then look at which system is actually going through. So that gets added to your frame, that MAC address. So now I can put it on the label and say, okay, it's going to system B. This is the address, right? So the system doesn't know, it has to learn who's sending and who's receiving. But if it doesn't know who's sending and receiving, it's going to keep asking. And when it keeps asking, you have floods. Okay. 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 Good question. What do you have any other questions regarding this? I know the concept is kind of high level, right? But when you see this problem, a lot of the times, your link lights is gonna show, and also you would, you would then trace back on how you would troubleshoot from a hardware to like cable ports, and then go access your configuration inside your switch. Okay. The difference between a regular unmanaged switch, those are the smaller switches that you would use to connect all of these desktops together or your devices together, compared to a managed switch. Is mainly that the managed switch, you can go into the configuration mode and be able to change and update your settings, to be able to add, right, your configuration. Like I can add a VLAN, I can modify the IP address, I can filter the port. Whereas an unmanaged switch, you just plug the cable in and you plug your system to that cable, and it's forwarding your traffic back and forth. So in a network, you would have many managed switch, right? And then you have some unmanaged switch to work with segments like where you're sitting. Can you have all managed switch? Sure, right? But the managed switch like these, or even better model, they are higher in price. So a lot of companies, they would use the smaller switches or even the unmanaged switch that handles many ports to be able to connect. Okay. And then they would have the managed switch at the racks or later in the part of the building, right? To be able, so each building like this will have a location where the managed switch would be. where the unmanaged switch would connect these computers together for you, right? For you to access the network, but the managed switch would be in one location. So that way it is more of like an easier way to manage that part of the network. So I can just go to that location, that physical location, that rack, to be able to configure, this whole entire segment, which might have 300 computers, right? Because you don't have a managed switch that have 300 ports. That's unheard of. Okay, so you would use the smaller unmanaged switch and then connect all of these devices together, the endpoint devices, and then reconnect those unmanaged switch to a managed switch, right? Because you might have 16 unmanaged switch connecting back to the big switch, which you can manage. So it spans, right? I mean, that makes sense because if you have an enterprise, you see that with national, Fortune 500 companies, you have global enterprises and you would have millions of endpoint devices. It doesn't make sense to buy, like thousands or even in the 100,000s of managed switch. That's like not cost efficient. And plus, and then when you add more devices, you hire more people, you expand your stores or your offices, it's not feasible. Okay, so let's now talk about VLANs. So we are gonna have labs specifically where you create your different VLANs. And keep in mind that, so RSTP and STP is there. Oh, I wanna touch on this a little bit. So we talked about how you configure your port, right? Remember, we have to be in the configuration mode, right? Once we're there, you type in the interface, which means that you're accessing the port and then the port ID. So when you see F0/3, this is the third port, right? And it is fast Ethernet. Okay. Sometimes you would see FA for fast Ethernet, depending on how they label the ID. So before you start, like I said, you should say show interface and it would list the interface for you. Okay. And then you can go from there. And then we talked about shutdown or no shutdown. So if you want to disable the port, you simply do a shutdown. So let's say that I have a 24 port switch and I'm only using 16, right? I want to shut down the other 8 ports so that way people don't just connect with the cable, simply an Ethernet cable connecting randomly, right? Or an attacker would do that. Even logically, so you would shut down those ports. That means you disable those ports. So if I want to disable port 24, I would say, right, I would access the interface, so interface F0/24 or 23, and then be able to say shutdown. That means I stop that port from having signal, right? But if I want to enable it again, then I do interface F0/23, and then I do a no shutdown. So turn it on, right? But out of the box, they're all turned on. So we can block ports that way. Okay, and then it talks about port bonding. So this is also known as link aggregation. So that means that you can use a group of ports together. You can combine them for bandwidth. So for example, I'm on fast Ethernet and you already saw the rate, right? I can combine 10 ports to give myself a higher bandwidth, right? Because each port is only going to have a certain throughput. So if I'm on gigabit Ethernet, that's 1,000 megabit per second. If I group 10 ports together, that's 10 times 1,000. You see? It's kind of like combining all the speed into that one pathway, so that way I can have higher throughput. Okay. So now here it says each switch can have up to 48 ether channel, and so we can take 16 of the 48 and we can aggregate them together by the channel, because ultimately they're just electrical signal. And we're combining the electrical signals so that way we just take each of the port speed and then be able to time it by 16. So that way we can elevate the speed. Okay. And you can do 2 ports, you can do multiple, that's really up to, and we do this also for VLAN. Okay, so a VLAN is a way that we can use a physical port on the switch and treat it as a separate network, a virtual local area network. So on a switch, I can have, well, depending on the switch model, I can have multiple VLANs. So for example, I can have VLAN 2, that will be for financial aid department at the college. I would have VLAN 3, that would be for admission at the college, for example, so you can segregate it for the departmental use because they might be using different connectivity for application purposes or servers, etc. And so that way and then you can we talked about aggregation, you can set priority for those ports depending on the need of the department. So in that case, we would do these things. Okay. First, when you turn it on, you type in enable to go from user exec mode into your privilege mode. Then you're going to go to configuration terminal, which allows you to go to the global configuration mode. Then you can start setting things. So if I am taking these 2 ports, which is 11 and 12 on my switch, right? I'm going to prepare those by doing a range. So anytime that you are grouping 2 or more ports together, you can say interface range and then the type of ports that you use. In this case, we're using gigabit Ethernet port 11 and 12, right? But you might have 10 or 20 ports. So you can say interface range, the type of port, let's say it's gigabit Ethernet, 0/ right? 10 to 20 for those ports, okay? And then to access the ports, you're gonna say switch port mode access. So you cannot use switch port on a router. I've had students get confused and they try to use switch port on a router. So, and some of the switch, it might not take switch port command, right? It would use a different type of command. So in most switch, you can say switch port mode access. So we are now accessing these ports, right? And then we are going to group them together for the VLAN label VLAN 2. Okay. Now some switch only have like the lower level switch. It would only allow you to do a default VLAN, only one, right? If the switch is capable of setting up VLANs and without limitation, you can group as many as you have physical ports for VLANs. Okay, and then we can assign IP addresses. So this is how you do it. And then we would do a channel group 5 mode active. So once we have the VLAN, we can assign IP address to the VLAN and we would activate the ports. And then you can get out of the mode by doing exit. Okay. Some of them take disable. The majority of them would do an exit so you can go from one mode to the next. Okay. So let's talk about the command. You would enable. You would do config term or configure terminal. You would do an interface VLAN 2 because the question asks you to go to VLAN 2 and set up an IP address for it. So once you are in the VLAN 2, right, you are going to do an IP address and put in the IP address and the subnet mask. This is a class A and the default subnet mask for class A. We will do subnetting next week, right, with IP. And then once I have that with an IP address, I would do a no shutdown. We know that this is to enable the interface and then do an exit. So this is how you can set up an IP address for your VLAN. And you can have like VLAN 12, VLAN 4, right? Now, if you already have a VLAN name, VLAN 2, you cannot reuse that same ID, right? And especially if you're using an IP address, because you don't want that conflict. So if you already created a VLAN 2, let's say you're a new technician and you come in and you're not sure, right? You say show VLAN and it's going to list the VLAN. And then you can say that, okay, VLAN 2 is already been set up. So I can set up a different VLAN name, like VLAN 4 or, whatever, right? So you want to be able to create a VLAN, but just make sure that there's no conflict in name and IP address. Okay. I see that as an error a lot in the labs in the past for the students, because if they did, like the prior student did reset the switch and they're trying to do the same lab and they're trying to type in the same VLAN name and it's throwing an error, that likely that VLAN already exists. So before you start, you just need to look at the VLAN table and see if it's already been named or created. Then you can create a different VLAN with a different IP address, right? Okay. If you want to add a default gateway, you would go into the configuration mode, right? You would go into the interface, and then you would do an IP default gateway and the IP address for your default gateway. And likely that it is a router, so it's a .1. Okay, compared to .3 as a different port IP for a host. Any question regarding these commands? Okay, so you can find the example on page 4. And then also the IP default gateway. The next section talks about power over the Ethernet, and then you got the PoE plus. So this is an Ethernet standard. It is 802.3, but power over the Ethernet, you see it's gonna be classified as a standard 802.3 AF. This is for the newer switches, and it uses the Ethernet cable for power. So that way you are not required to use just the power cable, but it's able to have 15.4 watts compared to power over the Ethernet plus, which is your PoE plus, that is EEE 802.3 AT. You might have to remember these things for certification purposes, right? So you would get higher power, almost 10 watts more, if you're using PoE plus. Okay. This comes up a lot in the networking classes like this and 40B or the other classes. So you would see for PoE. So the example that we use here is your voice over IP phone, like these phones right here, right? Each phone would have an IP address and they would be connecting to the switch. So it can use one port, and through that port, it would also receive power and data. So that's definitely convenient for call center if you are looking at voice over IP networks. Okay, so for VLANs, all ports are in default VLANs. So when you're looking at the VLAN table, you might have a default VLAN on some of the switch, and it would consider all ports, right? But you can set up your custom VLAN to use specific ports, like the physical port of your switch, okay? And all VLANs are then stored to your storage under a database. So you would use a database command to access your VLAN information. And when you use your VLAN command, it's going to then access the VLAN database, which contains the VLANs that you created or that exist. So in this case, if we're creating VLAN 2 for marketing department and VLAN 3 for the engineering department, we would need to go from your user exec mode into the privilege mode by using enable command. Then we're going to go into the configuration mode by doing config term. And then we are going to access the database for the VLAN by using VLAN database. right? And then we're gonna set up two VLAN 2, and we're gonna name it for the marketing department. And VLAN 3 is gonna be for the engineering department. Once that happens, right? This is not fully configured, but that's the task. Then you do an exit to get out of the configuration mode. Okay. Now, if you want to set up the ports, then we are going to go back to the configuration mode and then use the interface and the switch port access VLAN. So switch port access VLAN allows you to set up the port for the VLAN. And then we can group up the ports for our VLAN 2 and 3. So in this case, if you look at the commands that's follow, right? We configure port 2 to 2, 3, and 4 for VLAN 2, and then 8 through 12 for VLAN 3, right? So these are the steps. When you're done, you need to do a show VLAN right after you exit in the user exec mode to see your VLAN that you created. And make sure that the ports are associated with it. So when you do the lab in the future weeks, you're going to do these things where you would create your VLAN and set up your ports. At least for this class, I want you to leave this class with that kind of information. Okay, so we answer 17 that PoE is 15.4 watts and PoE plus generates 25.5 watts. To create VLAN number 4 for the finance department, you can use the example in the notes. So we would start with enable command. Then we would go to config term to access global configuration. We would then access the VLAN database by using VLAN database. And then we would create a VLAN 4 and we would name it for finance department using VLAN 4 name finance department. Once we do that, we can exit. Now, a later day, we can come in and we would be able to add the ports for our VLAN that we created from the previous question. So you would then start all over by accessing the mode. So enable config term to go to the global configuration mode. And then in this case, they ask us to take port 5 through 8 and set it up for VLAN 4. So you would say interface range fast Ethernet port 5 through 8. And then we would then access those ports and put them for VLAN 4. And then you would do an exit. And to confirm that your VLAN actually been created for these ports, you do a show VLAN in the user exec mode. Any question? So I want you to be able to put down this information, and then in the future, right, you can always reference these in the case that if you get stuck and you're like, oh, I don't know how to make a VLAN or group the port for the VLANs, you can come back to the notes and the assignments and it kind of walk you through on how to do that, right? In the lab, we'll have instruction to do that, but you will have to make multiple VLANs. And like I said, you cannot use the same VLAN name or the same ports that's used for another VLAN, right? So if someone had created the VLAN already, it's best to look at the VLAN first by doing a show VLAN before you start going into the configuration mode to change. Can you delete it? Yeah, you can. Right, but make sure that nothing is connected to it. You don't want to start deleting VLANs that people are still using. But let's say that no one's using that VLAN, then you can remove it. Okay, so we are gonna talk about trunking protocol. which is the next section of your notes. So the protocol that's used to create a list of VLANs from one switch and transfer it to another switch is called trunk with the T, right? And so we would do a VLAN trunking protocol or your VTP. This allows you to replicate, right, the same VLANs that you have from one switch to the next switch. So that way it allows us to not repeat the same procedure and process and move on to other things. It is convenient. Now trunking might not be supported in some modern switches because they, it is an older type of technology. Back in the day, this is how we're able to copy VLANs from one switch to the next, but so that way we don't have to recreate it for 100 switches, right? So we're able to use VTP. But on some of the newer switches, it uses a different type of protocol and service in order to do that. Okay. So if you trying to use it on some of the switch and it tells you it doesn't know what you mean by that command, that means that it doesn't support trunking. Okay. Some switch only has a native VLAN. That means that you are going to use that VLAN and that's it, right? We are not going, and you can just rename it. It doesn't support additional VLANs by default. So to use the command to configure the native VLAN, call VLAN 2, you simply do a switch port trunk native VLAN 2. Now, when you turn on a Cisco appliance, it's usually prompting you to set up an account, like a user account, and then password. A lot of them use encryption now to protect your access. So what you see is that technically you have to log in to access the configuration for your devices, right? But in the case that someone had disabled the login, what you can do is you can use a command called login local to enforce login. This is a way that we can go back to some of the old appliances in the case that the administration was lacking and people can just access the switch remotely without logging in, which is a security issue. So you can use a login local to be able to access or to enforce your login. Okay. Trunking information 802.1q, right? And it talks about trunk ports. So these ports are going to be responsible for connection. Trunk port carries VLAN packets. It is specifically made for VLAN. We can use this to go from one switch to the next. And then if the traffic is passed, what it does is it actually tags the frames by adding the VLAN ID. Remember that we talked about frame is the way that it prepares the data being passed from one part of the network or one system to the next. So because you're using VLAN with the trunk port, what it does is it's allowing you to, or it adds the VLAN ID, like VLAN 2 or VLAN 4 to your frame. So that way it knows that you are using VLAN from one switch A to switch B. And Cisco has a proprietary protocol for tagging packets. It's called ISL, so inter-switch link. And if you're using newer Cisco or other switches, it uses 802.1q. This is the standard for other switches or newer Cisco switches. But if you're using the older switches, it uses ISL for tagging. And VTP information is here, right? So native VLAN is also known as your default VLAN. This is when your switch receives from a trunk port and it's not tagged with a VLAN. So if it's not able to identify the VLAN, the system is gonna then automatically assume that it is a default VLAN. Okay, so if you don't have a VLAN ID, but it's supposed to be for a VLAN and it's not able to tag, then it's gonna default to the native VLAN. So this might be an issue if you intend for certain VLAN to receive data, right? But if it's not tagged as a VLAN ID, like VLAN 2, VLAN 4, VLAN 12, then it's gonna default to the native VLAN. So here's how you would configure the native VLAN 1. Okay. So make sure you access the port and then you would trunk the native VLAN like what we said in the assignment. Okay, port mirroring, I think we touched a little bit on this. So we basically take whatever data information that's passed from one port and we would mirror that to port, like port 1 to port 5. So whatever that's passed in port 1, port 5 also have the same information. We do this for monitoring and security reasons. So that way you don't occupy, because whenever that you're trying to assess a port, it would slow down that port. So you can just take the traffic from port 1 and mirror it to another port, so that way you can use the mirrored port to be able to examine your traffic and your data. You should do port security, as we would assign a port to a MAC address so we can filter. So one address per port. So what if they're spoofing your MAC address, right? You know, if you are filtering correctly, you should be able to detect that. But anyway, people still bypass it because the monitoring is not done correctly. Okay, so we talked about login local here. You can also log into 5 Telnet ports by using such command. We don't really use Telnet anymore. I don't recommend it, but in the case that if you still have, if the network is still allowed to do that, you would see that. So VTY here, 024, that gives you 5 lines. Okay, so it talks about troubleshooting. For Network Plus, you need to know how to troubleshoot. And logically, we can go through the procedures to look at hardware and configuration. So for layer 1 and layer 2 switch, the switch that don't have routing capability, you check for loops, right? But I always start with hardware. I always look at link light and cable. Then you can go into configuration and see if those things already been checked out. So once you check for link light and cable and power, then we would check the configuration. So we would check for loops. We would check for configuration for the port. Is the port identified to specific system MAC address and also VLAN information, right? And if there is a mismatch MTU, is there a power failure, like I said before, with the hardware, or bad modules? So sometimes if you have switches that are running out of storage, or if it's dated, they get deteriorated. So, you know, we always want to plan to upgrade. And then for the layer 3 switch, which answered the last question, because it is also a router, we want to make sure that we check routes, right? After we check the hardware, we check for subnet mask, right? Sometimes the CIDR could be wrong. We check for the right gateway, right? Check the IP address for the gateway. If there's a conflict with IP address, it will not work. And then sometimes that could also be linked to DNS for your domains. So you can refer to these general, but we're not just limited to these, right? But in general, you tend to see these are the common problems. Okay, any question? So we don't need a drive today for our labs. You are going to use Packet Tracer, which has already been installed on the classroom computer. If you're using your own laptop, you can install Packet Tracer, but in order to download, you have to have an account, and you can use your RCCD email to create an account. We have Cisco Academy through the college, but I think and I tried to access Cisco Academy with the packet tracer that they installed here. If you're using certain version of packet tracer that's older, you have to do the skill access, which is the green option on the right when it prompts you to log in. So you have to create an account. I'll walk you through some of that if you haven't done that before. But if you had created Cisco Academy maybe for high school, Cyber Patriot, or other things, you can always activate your account. Cisco Academy is generally free for the public, right? But if you want to access some courses that is not free, then you have to have the license through the school or through UPay, right? There are courses on Cisco Academy that is great, like the IoT courses, Packet Tracer in extension. So I'm giving you some exercises, but you should try to, when you have time, take the Cisco Academy courses so that way you can learn more in depth about Packet Tracer or about network systems. Those are the free resources that you have, and that's going to be helpful. Okay. So I'll stop the video, take attendance, and then you can take a short break, and then we'll come back. We'll do the lab. You don't need to do the last exercise. It should say optional part B. We will do that as part of lab 8. So you can go from A through C when you get to, and it seems long, but it's not. It's very fast. My class, they finish with like lots of time to spare. So on Monday. So what you can do is you can go through, and then I would encourage you to continue to practice on Packet Tracer. It's a good simulator for you to practice Cisco devices. So and systems in general. Okay.